Well, so in the last video, we had the cliffhanger when the wife came in and said, Walkies. So here we are now, and it's time for us to review again. This is probably the single most challenging thing that students face in the course of this unit, which is how do I know when I go around that number of times versus not going around that number of times? So, yeah, when I see that number in there, only with 0 to 2 pi solutions do I go around that many times, picking up solutions. When I have all solutions, I'm only going to go around once. I'm going to slap on that plus 2 pi n, unless I'm dealing with tangent or cotangent, and then I'm going to slap on a plus pi n. And finally, I have to divide my answers from going around just once by that number. In this case, that number is 3, and so I'm going to divide all my answers by 3. And that means not just dividing the number that I have here. So, for example, sine is equal to 1/2 at pi over 6 and at 5 pi over 6. Here we're saying, okay, don't forget to plus 2 pi n and plus 2 pi n. But this is now step 2. We added the plus 2 pi n. And step 3, we want to go back and divide everything. Not just here, but here as well. Not just here, but here as well. And so our answers should end up being x equals pi over 18 plus 2 pi n over 3 and 5 pi over 18 plus 2 pi n over 3. Okie doke. That's noteworthy. I think so. All right, well, let's take a look at station 10. Station 10 is another solving situation, and in this case, we've got station 10. We're told we're only looking on 0 to 2 pi, and our first problem says 2 sine squared theta minus 1 is sine theta. And really, I would love it if you saw this as 2x squared minus 1 equals x and said, oh, look, I got to move that x over there so that I'm in a position to factor a trinomial and set those factors equal to 0. That's exactly what I want to do with this tricky thing. I do want to subtract sine from both sides. And so we're going to have 2 sine squared minus sine minus 1. And sine minus sine is 0. This is factorable. Now what about the SIGNs? Should this be plus or minus? Well, because we have a minus 1 here, we want the bigger value to carry the minus and the smaller one to carry the plus. We need them to be different SIGNs because this is negative, so we need a positive and a negative for that. And since this is negative, we know that the bigger one, 2 sine theta, as opposed to 1 sine theta, the bigger one has to carry the negative. So I'm going to set each of these factors equal to 0, and I'm going to get sine equals negative 1/2, and sine equals 1. Well, we know that sine equals 1 when theta is pi over 2, and we know that sine equals negative 1/2. Well, it's true, negative pi over 6 is a place where sine is negative 1/2, but we have to be within 0 to 2 pi. And so my answers here are going to be 7 pi over 6 and 11 pi over 6. So we get these 3 solutions. Okay? I mean, you could always graph this on your graphing calculator. Set x min equal to 0 and x max equal to 2 pi. And you've got these to find, so I'd probably change my x scale to be pi over 6. But then you should see, in fact, these 3, well, I guess you could do it 2 different ways. You could graph this in y1 and this in y2, and then you'd see the points of intersection occurring at these points. Or you could take this equation and graph it and see that the x-intercepts are at these points. Okay, so that's number 1. How about number 2 on station 10? Negative 4 plus 6 cosine beta equals negative 7. Many students get upset because Cooper is using this other Greek letter. Look, you were okay with epsilon, you were okay with A, and it's just a letter. Just, got tired of writing the same thing all the time. My process is still the same. I'm going to add 4 to both sides. And I'm going to get 6 cosine beta equals -3. I'm going to divide both sides by 6. And it's going to give me cosine beta equals -1/2. And I'm going to say, okay, cosine is the x value. When is the x value -1/2? And so beta is going to be 2 pi over 3, or 4 pi over 3. Ta-da! Remember, we were only looking at 0 to 2 pi for solutions in this problem. So there's station 10. How about station 11? Station 11 is all solutions, and here we're given things that have a similar structure. Station 11. First problem says 2 cosine squared x minus 1 equals 0. All right, well, I'm going to do that solving and get to this place. But now what? Well, I don't want cosine squared, I just want cosine. So that's going to mean I have to take the square root of both sides. And you might remember that I really want you to think now, when you take the square root of both sides of an equation, you need to remember the plus and minus. Now, this is fine, but no one recognizes when cosine is equal to that. So let's manipulate this a little bit based on what we did in our Algebra Basics unit. I'm going to hold on to that plus minus, but I'm going to split this into 2 radicals. And then I'm going to rationalize the denominator. And even though I'm often one to say, why do we need that anymore? Do we have to keep rationalizing denominators? Slide rule isn't a thing. Well, it turns out this is the only reason that I think we need rationalizing the denominator. In calculus, we definitely want to be able to rationalize the numerator, but in trig, yeah, really, this is the reason. Because now I'm going to have plus and minus root 2 over 2. And I know when cosine is equal to plus and minus root 2 over 2. See, I didn't recognize this as that. And that's why in trig, I think, this is still kind of important for us, this rationalizing. So when is cosine either positive root 2 over 2 or negative root 2 over 2? That's at all the pi over 4s. Remember, we want all solutions. So we'd only go around once. Okay, let's go around once. We're going to have x equals pi over 4 plus pi n, 3 pi over 4 plus pi n, 5 pi over 4 plus pi n, and 7 pi over 4 plus pi n. So why pi, not 2 pi? Well, the period for, yeah, no good reason, Mr. Googler. You're asleep. These should be plus 2 pi x. See, it's good to think about your work and why you do what you do so that maybe you catch some of the mistakes you're making. There we go. Nice. Okay. Though I do think I noticed something here. Pi over 4 and 5 pi over 4 are pi apart from each other. So instead of listing both of these, I could list just one of them, provided I made that change. And here too, 3 pi over 4 and 7 pi over 4, that distance is only pi apart from each other. The distance from here to here is pi, so I can get rid of this and make that be pi. Or, like I showed a little while ago in the first part of the video, these are all pi over 2 apart. And so really, we could go with pi over 4 plus pi over 2n. That would be my preferred solution, or my multiple choice solution. I wouldn't mark you wrong for writing down this solution. 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. So here's the thing. Writing all that out, that takes time. It takes time to write this stuff down. I just need to write one thing. When in doubt, go with the sure thing. Okay. So that was problem 1 on station 11. Now this one is still all, but now we've got a b value in there. So we go quickly to this place, and then we took the square root, and we said, hey, don't forget the plus and minus. This is where we rationalized, and so we get root 2 over 2. Oops, and we took the square root already. All right, now since this is all, I'm only going around once. So 2x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And because we're talking about cosine, we want to slap on these plus 2 pi n's. But that's what 2x equals. So we need to divide everywhere by 2 still. 2 here, and 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 here. So my final answers now will be x equals pi over 8 plus pi n, 3 pi over 8 plus pi n, 5 pi over 8 plus pi n, and finally 7 pi over 8 plus pi n. Okay, so all of those will work. Now, remember how we said, oh, look, these are all pi over 2 apart from each other? Okay, so how does that work? Well, so let's imagine we have gotten to this place, pi over 2. Well, I'm still going to divide everywhere by 2. And so now I end up with x equals pi over 8 plus pi over 4n. That's a very tidy solution. I like that one. Again, you need to do this, you do this. These shouldn't be 2 pi's, though. These are pi's. You really need to divide everything by that 2. And the signal that you didn't is if I see pi over 8 plus 2 pi n. Pi over 8 plus 2 pi n, you didn't divide everywhere by 2. You only divided the angle values, not the plus 2 pi n. Okay, so watch out for that. All right, that was station 11. Station 12 is another all solution situation. I'm sorry, station 12 is another all solutions. And here we have for problem number 1, -3 minus 4 tangent x equals 1. So let's add 3 to both sides and get -4 tan x equals 4. And if we divide both sides by -4, now we're saying when is tangent x equal to -1? Well, I know in order for tangent to be equal to -1, the sine and cosine values, or the y and the x values, need to be opposites, right? I need to have a number here and a number here, and one of them is going to be negative and one positive, or one of them is going to be negative and one of them positive. So where does it happen that the sine and cosine of the x and y values are the same on the unit circle? Well, we know that to be true at 3 pi over 4. You might say 7 pi over 4. Some people say -pi over 4. So here's the thing. We're doing all solutions, and so it's not going to matter which of these we use. Think about this graphically for a moment. You've got tangent graph. Okay, so there's -pi over 2, there's -3 pi over 2, there's pi over 2, and there's 3 pi over 2. Tangent graph. And tangent graph. And so our tangent graph looks like this. Now we're asking, when is this tangent equal to -1? Well, I see a point of intersection here, somewhere between pi over 2 and 3 pi over 2. And that answer was 3 pi over 4. And then there's this other one here at -pi over 4. In fact, if I draw another period of tangent, I get this one here at 7 pi over 4. How far apart are all of these solutions? Well, they're all one period apart. The period for tangent is pi. These are all pi apart from each other. So, I could say that sorry, Justin just sent me a text. I could say 3 pi over 4 plus pi n and 7 pi over 4 plus pi n. But again, no, because this, if I add pi onto that, I get this. So I don't need that. I don't need -pi over 4. That's all I need. I could certainly write -pi over 4 plus pi n. That would work. Yeah, so I do want some thinking. Okay, part B. Ooh, there's a p-value in the second problem. -3 minus 4 tangent 3x equals 1. And so we get to that place pretty quickly where tangent 3x equals -1. I'm going to add 3, which will have 4 divided by -4. I get -1. And again, we're looking for all solutions. And this time we only go only once around. Okay, so when is tangent equal to -1? Well, tangent is equal to -1 at 3 pi over 4 plus pi n. But that's what 3x equals. And if I divide everywhere by 3, I get x equals 3 pi, well, I guess I could cancel. Just get pi over 4 plus pi over 3n. Okay? Now, if you were that other student, if you were the student who wrote down 3x equals 3 pi over 4 plus pi n and 7 pi over 4 plus pi n, when you start dividing, you've got a lot more stuff. In fact, twice as much stuff to divide. And we get x equals pi over 4 plus pi over 3n, and we already know that's a complete answer. That includes everything. But we could also write 7 pi over 12 plus pi over 3n. I don't like the repetition. It's not wrong. It's just duplicative. It's a waste of your time. Don't be afraid to think about it so that you don't have to waste your time. Your time is very important to me. Okay. Station 13. There we go. And again, with station 13, we're looking for all solutions. So, problem number 1, 4 sine squared x minus 3 equals 0. And that's going to be sine squared x equals 3/4, because we're going to add this and divide by that. Yes, we're going to take the square root of both sides. Yes, we're going to remember the plus and minus. Yes, we're going to split this up into two radicals, because I don't recognize this, but I do recognize square root of 4 is 2. I do recognize this from my unit circle, okay? So, yeah, don't do that. Do this and get yourself here. All right, so when does sine equal plus or minus root 3 over 2? Well, that happens at the pi over 3 places, like x equals pi over 3 and 2 pi over 3 and 4 pi over 3 and 5 pi over 3. Now, you could, of course, now slap the plus 2 pi n on to each of these, and again, Not pi like it was for tangent, but 2 pi because the period of sine or cosine is 2 pi. That's why we're using 2 pi here. Okay, great. That's fine, nothing wrong, but it is duplicative. Oh my goodness, is it duplicative? Yeah, so let's think about this. Here's pi over 3. Here's 4 pi over 3. These are only pi apart. And because they're only pi apart, instead of having this and this, I could just write that. Likewise, we have the same thing happening here. We have 2 pi over 3. We have 5 pi over 3. And again, they're pi apart from each other. So instead of writing this and this, I could just write one of them. Okay, so those are going to be my answers. Your answers may vary, but please don't let them vary so much that they're wrong. All right, the second question here, same problem, but this time with a b value. So problem number 2, 4 sine squared 3x minus 3 equals 0. Okay, so that's sine squared 3x equals 3/4, and we do that square root, and we get sine 3x equals, don't forget the plus and minus, root 3 over root 4, which is 2, and we say, okay, sine is equal to plus and minus root 3 over 2 when we have pi over 3 plus 2 pi n, and 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n, and then finally 5 pi over 3 plus 2 pi n. Now you can do this. It's not wrong. It's just a lot of writing. Divide by 3, divide by 3. You must divide by 3 here too. Come on. This is like the single biggest mistake on this next assessment. People who divide over here by 3 and not over here by 3. Because they don't figure out to put the plus 2 pi n before they divide. It's not divide and then slap on the plus 2 pi n's. No, that doesn't work. It's slap on the plus 2 pi n's and then divide by the b value. 3, 3, 3, 3. And so I'm going to get all these answers, and I'm going to be pretty unhappy because it's a whole bunch of writing I don't want to do. X equals pi over 9 plus 2 pi n over 3, and 2 pi over 9 plus 2 pi n over 3, and 4 pi over 9 plus 2 pi n over 3, and 5 pi over 9 plus 2 pi n over 3. Oh my goodness, that's so much work. Can't we at least just recognize that? And maybe the answer is no. In which case, yeah, that'll work. But look, these are pi apart from each other. So I don't need both of them. And these are pi apart from each other. So I don't need both of them. I could just slap on plus pi n instead. And now I'm going to do this. Now I'm going to divide. And so what happens? We get x equals pi over 9 plus pi over 3n, and 2 pi over 9 plus pi over 3n. And that's so much less writing than all that. I understand, but really, it might be worth learning. Okay, that was station 13. How about station 14? You know, by the way, one of the reasons you're seeing the same problems in the 0 to 2 pi and the all solutions case is because a lot of people are only comfortable with one of them. And I want you to be comfortable with both. Also, knowing how to deal with that b value when we're on 0 to 2 pi versus when we're on all solutions. So, station 14 says we're find all the solutions on 0 to 2 pi. Yeah, it's all solutions, but it's only on 0 to 2 pi. So we're not slapping plus 2 pi n here anywhere. All right, Sine squared x plus sine x equals 6. Oh my goodness. If you are this person, if this is your inclination, please message me and group me so that I can come over to your house and chase you with a stick. Because, oh no, 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 no. See that? That is greater than first degree. So you want to move everything to one side. And now you want to factor that trinomial. Please don't bring your bad algebra skills into trig. That's a plus, that's a minus. And what do you notice? Well, sine minus 2 should be 0, which means sine should be 2. And sine x plus 3 should be 0. And so sine should be negative 3. And then what do you say? Well, I know the graph of sine. You're not going to trick me, Kukla. Graph of sine looks like this. And I know that that y value never goes higher than 1 or lower than negative 1. So what angle has an upness of 2? Not on the sine graph, there's no upness of 2. What angle has an upness of negative 3? No, I only go down to negative 1. This never happens. So this is no solution. Okay? Now, is this still going to be true for tangents? Well, let's take a look here at problem 2. We have tangent squared x plus tan x equals 6. And again, please don't be this person. No, 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 no. Don't do it. I really think that if you continue to make this mistake at this level of class, after I yelled at you all those times in pre-cal, it's willful disobedience. Either that, or it's really not paying attention to what you're doing. Because you've probably been making this mistake for a couple of years now. Come on, stop it. It doesn't help your math self-concept to continually get the same problem wrong. Learn from your mistakes. Okay, tangent squared x plus tangent x minus 6 equals 0. And that factors tangent x plus 3, tangent x minus 2, and again I'm going to set each factor equal to 0. So I'm going to get tangent x equals negative 3, and tangent x equals 2. All right, well, I have no idea. Now, what I do know is I do know the graph of tangent. And I do see that in even just one period of tangent, yeah, I'm going to have y equals 2, a point of intersection. And I'm going to have y equals negative 3, a point of intersection. Yeah, and since this is 0 to 2 pi, so I can fit 2 periods of tangent in there, I expect to have 2 of these and 2 of these. So how do I want you to do it? Well, you know, old school, Mrs. Goldman taught me to do this. Oh, sorry, I thought I was looking at tangent squared. Ms. Goldman taught me to say, well, if you want to get x by yourself, take the inverse tangent to both sides. So inverse tangent and tangent cancel, and we've got x equals tangent inverse negative 3. Okay, that's one of the answers, but remember, this is supposed to happen twice. And yeah, furthermore, I'm worried that this answer is outside of this restriction. This is going to give us a negative angle. Yeah, you don't believe it? Yeah, let's take a look. I've been rating this good, so inverse tangent negative 3. And I get negative, ooh, it's in degrees, sorry, but maybe this is better. No, that's not 0 to 2 pi, so this answer is completely worthless. So, you know, old school is nice for some things. You know, go for a sleigh ride. Old school. But, yeah, here, no, I really think the best way to do this problem, the best way to figure out when tangent equals 2 or when tangent equals -3 is going to be to graph. And I don't mean by hand. I mean go to your calculator, type in tangent x, type in 2, and we want x min to be 0. We want x max to be 2 pi. I don't have a sense of any particular scale to use. And now my y min and y max, if I were doing sine and cosine, I'd only want to go -1 to 1. But here I want to see at least +2 and at least -3. So if you need to muck around, how about -5 to 5? Okay? So let's graph. Radians. There we go. Okay. So how many points of intersection do we see? Oh, we see 1, and there's our second one. Now this solution turns out to be x equals tangent inverse of 2, and this one period away, is tangent inverse of 2 plus pi. This one, when we did the inverse tangent of -3, we actually ended up with something not in this picture. So let's come down here and change this to -3 and find some values that are in the picture. And here's -3, and I get 2 solutions. So let's find those solutions. Second, calculate intersect. Bring my cursor close to a point of intersection. And hit enter, enter, enter. Okay, I get 1.893. But there's also this solution, which is pi away from that. So if I took this and added pi to it, I'd get this next number. But some people don't remember that, so let's just find it for them anyway. Of course, you have to just sort of keep going and keep going and keep going and keep going and keep going, because I want to be near this point, and I definitely want to be past that asymptote. Oh, there we go. Enter, enter, enter. And I get x equals 5.034. So those are 2 solutions, and then these, inverse tangent of 2, inverse tangent of 2, I get 1.107, and if I add pi to that, I get 4.249. So there are my 4 solutions. I can either do second calculate intersect to find them. I could go old school, but remember, old school had this really big problem that this is not on 0 to 2 pi. Okay? Be careful about that. So that was station 14, and now station 15, our second to last station. Let's see what we come up with here. Okay, we've got cosine squared for station 15. Problem number 1, cosine squared plus cosine equals 0. Now, in this case, yes, I do GCF factor. Don't forget that cosine divided by cosine is 1, not 0. And so we get cosine x equals 0 and cosine x equals -1. This is all solutions. So when does cosine equal 0? Cosine is the x value. X value is 0 at pi over 2 and 3 pi over 2. When is cosine -1? That only happens at pi. So many students, because this is all solutions, now say plus 2 pi n plus 2 pi n plus 2 pi n. And, I wouldn't mark you wrong for that. I'm not sure about Mr. Paz. He might mark you wrong for that because it's not as simplified as possible. Because look, we know here's pi over 2, here's 3 pi over 2. That distance between this solution and this solution is pi. And the distance here, that's another pi. You don't need to write both of these. You just need to write one with a pi. This would require 0, but at the angle of 0, cosine, the x value at 0 is 1, not -1. So no, I can't simplify that. So these are my solutions for problem number 1 on station 15. How about problem number 2? Problem number 2, look, it's a b-value. Yeah, so guess what? B-values are really hard for some students. So let's just please make sure we know what we're doing. We're going to factor out a cosine 2x from each of these. It's going to leave us a cosine 2x plus 1. And so we want cosine 2x equals 0 and cosine 2x equals -1. Remember, when we're doing all solutions, we only go around once. Okay, so when is cosine equal to 0? Well, we said that that was going to be at pi over 2 plus 2 pi n, or 3 pi over 2 plus 2 pi n. And then we would divide everywhere by 2. So, this is an answer. It's not wrong. It's just repetitive. Yeah, it's just repetitive. Pi over 4 plus pi n, 3 pi over 4 plus pi n. But hold on a second. Let's think about this. Didn't we say that these answers were pi apart from each other? So I didn't need to write both of them, just one of them with a pi? Yeah. And so now when I divide by 2, I would prefer to see this. I'm not going to mark that last one wrong, but this is what you're going to see when you look up the answers in the back of the book, or when you take the U of A math placement test. All right, and what about here? Well, we know that cosine is -1, only at pi plus 2 pi n. If I divide everywhere by 2, I'm going to have x equals pi over 2 plus pi n. So that's going to be my solution to the second problem on station 15. All right, here's our last station, station 16. We're now on 0 to 2 pi. Oh, look, it's the same problems we just did on station 15, but now with a different restriction. Instead of all solutions, we're just looking for all the solutions on 0 to 2 pi. So we've got cosine squared x plus cosine x equals 0, and we do that GCF factoring, and we get cosine equal to 0 and cosine equal to -1. So when is cosine 0? Well, that's when the x value is 0, and that happens at pi over 2 and 3 pi over 2. When is cosine, or the x value, -1? That happens just at pi. These are my 3 solutions on 0 to 2 pi. Okay. The last problem, cosine squared 2x plus cosine 2x. This is the time on 0 to 2 pi with a b value. This is where I have to go around twice. Okay, so we have cosine of 2x times cosine of 2x plus 1. We set each of those factors equal to 0. And I say, okay, when is cosine equal to 0? But I have to go around twice. The first time I go around, I get pi over 2 and 3 pi over 2. That's once around. Now I need to go a second time around. To get a second time around, I'm going to add 2 pi to each of these answers, which is 4 pi over 2. So I get this, and I get this. Remember, we need to divide everywhere by 2. And so I get x equals pi over 4, and 3 pi over 4, and 5 pi over 4, and 7 pi over 4. Some students stop there because they feel like they've done a lot of work, but don't forget we've got this as well. So when is cosine equal to -1? Well, we said cosine was equal to -1 when x was equal to pi. But I have to go around the unit circle not just once, but twice. So if I add 2 pi to this, I I get 3 pi. Okay, divide by 2, divide by 2, divide by 2. So in addition to these 4 solutions, I also have pi over 2, which I guess is 2 pi over 4, and I have 3 pi over 2, which is 6 pi over 4. Isn't that interesting? You have pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. 4 pi over 4 is missing. All the others, though. Okay. All right. Well, that's that one. Yes, that's the last one. Okay. Really, this stuff is pretty straightforward. You've got to figure out 0 to 2 pi versus all solutions. You've got to figure out what to do when we have a b value. If I have that b value and I'm on 0 to 2 pi, I have to go around b times, picking up solutions. But if I've got that b value for all solutions, well, I'm going to go around only once. I'm going to slap on the plus 2 pi n or the plus pi n, and I'm going to divide everywhere but that b value. Okay? All right. Well, I hope this is helpful, and I look forward to seeing you in our next video. Take care, everybody.